Now that we've prepared all of our data for our cost path analysis, we can start to think about creating that resistance surface, or essentially the best, or how we're modeling in my case of the hiking, that my most preferred path across San Diego County. If you're thinking about the lab with the deer migration, it may be we're looking at the risk associated for those deer for different paths. How do we create that path of least risk for deer in terms of getting hit by a car or on terrain that they don't want to cross? You could think about your resistance surface being time, just what's the fastest route, what's the route that's going to, if you're a delivery service, wear your tires the least and cost the least in terms of maintenance on the truck or gas. Energy expended. Again, you can think of gas, but you can think about yourself as a hiker too. So we created and prepared land cover, public ownership of the land, trails, and slope or elevation. They all have been converted to raster data. And now we're at the point where we're creating that resistance surface. Like a suitability analysis, we have to come up with preference. In my case, I'm looking at preference. It could be risk or dollars or costs across the top. So I went ahead, when we did that reclassification, that's what we were doing. I was ranking them based on my preference for hiking, safety for hiking, risk, whatever you want to look at it. Like I don't want to swim, so we're not even including it. You could list this as 0 too, but now we're moving to the point where we're going to be using the raster calculator to combine these four surfaces, 4 layers of raster data, 4 raster data sets to create that resistance surface. You do have that option now to rank or to weight our surfaces when we're using them in the raster calculator. So I'm going to keep this simple and keep it a lot like the suitability analysis we used before, just for consistency. We want to rank our data layers according to how important they are for the overall analysis for my preference. So I sat and thought about this. It's like, is it more important to me that the area is flat, or is it more important that I'm not, or is land cover more important? So trying to figure that out. So using that same 1 to 3 scales we used before, I ranked 3 is most important for land cover. I really don't want to be hiking through really developed areas. And then I ranked public ownership and slope as 2 because I felt that they were both about equal. And then trails were least important, mostly because when we looked at that data, we saw there weren't a ton of trails. So, if I can get on a trail, great. If not, that's fine too. This math that you're seeing here to create that percent weight, let me try to bring this up. Why can't I move it? There we go. Oh, it's not on this one. Yep. So to get the percent weight, what we're doing is we're looking, the relative weight is equal to 100 divided by the product of the sum of all rankings. But what that means is we're going to add all the rankings together. So 3 plus 2 plus 1 plus 2 equals 8. Then we divide 100 by the 8. This should be the 8. Sorry, that's left over. 100 by the 8 because we want our weight to be equal to 100. And then we multiply it by whatever the assigned rank. So 100 divided by 8 times 3 is 37.5. 100 divided by 8 times 2, 25. And then 100 divided by 8 is 12.5. We then move the decimal point over to get the multiplier, so it equals 1. And this is what's going in our raster calculator. So we'll keep track of these. I like to keep track of them. Definitely keep track of them when we go into our model. So this is where we are. I pulled in the raster calculator tool, so just search for raster calculator. The spatial analysis one, you'll click on it and you'll get it added in. And you can see when let's just look at it when I just hover over it. You can see when I hover over it, it previews that map algebra expression. So you can see my multipliers put in there for each of the classes. We can open it so we can actually see that tool and see that I used a lot of parentheses to make sure it was being done right, but use that intermediate layer. That's why you're seeing the percent times that multiplier. So your multipliers may be different based on your calculations. And then you'll click OK after you make sure you get them all in there. You can, it will give you warnings if you're missing like a plus sign or a parentheses. So make sure if you have a little red X here or the yellow and black exclamation point that you go back and check. And then we'll click OK to run. We'll click OK, and then you can click on Run, which it doesn't look like. Ours is Run because there's no drop shadow behind it, so it's just going to take a second or two. And we get a notification that it's done. And you can also see that it's covering, again, the, or it's pulling up the formula you used here. So we can go ahead and add in that data. If you're wondering, another way to add in that data set, since it is a permanent data set that we created, it'll be in our geodatabase, and that was our raster calculator, so we can right-click Add to Current Map. It'll build its pyramid so it displays faster. Let's turn off elevation. And you can start to see, where did it go? Let's bring this up. All right, we can start to see our results, and you can see that it's showing the least preferred areas in the black. I want to go ahead and invert that so our most preferred areas are in the dark colors. So we can start to see as we get further east, we're seeing the more favorable areas. As we get towards some of the more developed areas, it gets less favorable. You can see the areas that we've excluded or that have no data, which you can see is going to sort of impact getting us from our starting location to our ending location. So this is another reason why it's good to use a model, because we can go back to our raster calculator and adjust if we need to later. Oops. Okay, so now we're at our, so using our raster calculator, we've created our resistance surface, and in the next video, we'll take a look at doing that creating the actual least cost path.